This quick video is going to help you guys be able to do some of the problems on your Battleship project. So you're going to be given vertices or points on our functions, and then an additional point that the function goes through, and asked to find an equation between those. So basically we're doing non-linear equations between 2 points. So everybody can do a linear one. Okay, but what if you had to connect a parabola, or you had to connect a square root or an absolute value? So that's what we're going to help you guys out with here. So 2 examples. First one, I tell you a parabola's got a vertex, and I tell you it goes through a point. So let's just think about a picture so we have an idea what's happening. Negative 6, 3, we'll call that our vertex. It goes through 8 and negative 46, so we'll just put that down there. So clearly the parabola has to do this. You know we got a line of symmetry, we can reflect that over like this. So it's going to be upside down. Clearly there's some stretching, shrinking, and all that stuff. So think about a general form for a parabola. H, K, and the A value. If they give you the vertex, they're already giving you H and K. So you can write this right now as this. The only thing missing is that A value. We know it's negative. Is it negative 2? Is it negative 7? Is it negative 3/8? What is it? That's what we need to find. They give you HK, they give you a point. That's any XY. So now, go throw this in for Y here, go throw this in for X, and you got one missing variable. Okay, so let's start solving and simplifying some stuff here. So this is 14 squared plus 3. Now, make sure you take this 3 away. That's usually a common mistake with kids. So we do this, we get negative 49. 14 squared is 196. Let's just throw the A at the end. It's just like saying, you would never say x2, you'd say 2 times x. So then we just divide, and we divide. You just solve for that A value. It's negative, that's good, because we know it's upside down. It's a 1/4. Okay, so that actually made it a little bit narrower, but we don't know that just because kind of how the points go, so we have to trust the math here. So the only thing you need to do now is come back to your original and just say, I found the A value is negative 1/4. If you want to check that you did this correctly, go to your calculator. Y equals negative 1/4 x plus 6 plus 3. Go to your table. When you plug in an 8, you get negative 46. When you plug in a negative 6, you get 3. So that looks good. Next, square root ones. So we get a square root equation that starts at 6, 8 and has another point at 10, 12. Again, look at a picture just so you can visually see it. 6, 8, we'll put it right there. 10, 12 would be right here. So this would go up like this. You could easily talk about domain and range and stuff as well. So they just gave us the H and the K. They gave us an X and a Y. So any generic square root equation is going to be A times the square root of X minus H plus the K on the outside. So let's throw in our vertex. It went right 6 and up 8. Okay, H's are always opposite signs. They give you an X and a Y. Go plug it in, and let's solve for that A value. that shouldn't be a 4. It should probably still be a 6. Now, make sure you subtract that 8 first. Okay, you're basically solving an equation. So this is a square root that's twice as tall. Go back to your original. Throw in an a value of 2. It shouldn't be negative because it's opening up. Whoops, that's probably not the one we want. How about this? You always want to have x's and y's in your equation. Again, you could throw that in your calculator. You could go to the table and the points would match up. So that should help you guys out with some of the back of the Battleship problems. Any other questions? Obviously, just come and ask.